So in this video, I'm going to explain 6 of the most useful concepts in Python that everyone should know. Let's start with the very first and most basic concept in Python, variables. Now, what exactly is a variable? Think of it like a container or a box where you store some information. Just like you might put your clothes in one box and your books in another, in Python, we use variables to store data. For example, let's say we create a variable called name and we assign it the value Mike. Then we create another variable called age and we assign it to Mike's age. So now whenever we need to access Mike's name or his age, instead of rewriting them again and again, we can simply use the name and age variables. If we run the program, you'll see that Python prints out both values. Now, what happens if we assign a new value to the same variable? Let's say we create a name again, but this time we assign it to Bob. If we run the program now, you'll see that the variable no longer points to Mike. Instead, it now points to Bob. All right, now let's talk about the rules for defining variables in Python. Variable names must start with a letter or an underscore. If you try to start a variable with a number or any other symbol, Python will throw an error. Variable names are case sensitive. That means a variable written in lowercase and the same variable written in uppercase are treated as two different variables. You cannot use reserved keywords as variable names. For example, class is a reserved keyword in Python, so using it as a variable will cause an error. Finally, variable names cannot contain spaces. Instead, we use an underscore to separate words. Now, let's talk about data types in Python. In Python, every variable stores some kind of data, like numbers, text, lists, and many more. And the best part is, you don't have to manually specify the type. Python automatically decides the data type when you assign a value to a variable. First, we have the string data type, which belongs to the str class. A string is simply a sequence of characters enclosed in either single quotes or double quotes. Inside the quotes, you can put text, numbers, spaces, or even symbols. Python will treat all of that as a string. But remember, you must use matching quotes. If you start a string with a single quote and end it with a double quote, Python will throw a syntax error. We also have multi-line strings, which are created using triple quotes. And with strings, you can also perform concatenation, where you join two strings together using the plus operator. Next, we have the integer data type, or int. Integers are whole numbers. They can be positive, negative, or 0. With integers, you can perform all the basic arithmetic operations just like in math: addition, subtraction, multiplication, division, floor division, modulus, exponentiation, and more. Now we have the float data type. A float represents a number with a decimal point. Just like integers, they can be positive, negative, or 0. Integers are great for whole numbers, but in real life, we often deal with fractions, prices, percentages, or weights. That's where floats come in. And just like integers, floats support all arithmetic operations. Another data type is complex. A complex number has two parts: a real part, like a normal number, and an imaginary part, which is written using J in Python. So anything that is written in the form of something like 5 plus 10j, Python will consider it as the complex data type. Now, here you can access the real part of a complex number using the .real, and to access the imaginary part, you can use the .imag. Then we have the Boolean data type. Now, a Boolean can only have two values, either true or false. Notice here that true and false always start with a capital letter in Python. Now, usually Booleans are the result of comparison operators. So whenever you do some sort of comparison in your code, Python gives you the Boolean output. Always remember, every non-zero value in Python is considered true, and all the zero values are considered false. Now we have a list data type. A list is basically an order collection of items. A list is used to store multiple values, either of the same data type or different data types. To create a list, we use square brackets, and then we put all the elements inside these brackets separated by a comma. Now, the list belongs to a mutable data type, which means we can change the content of the list once it is created. Like we can add or remove any item from the list. Now on lists, we can perform different methods. Like we can use the append method to add a new item at the end of the list. We can use the insert method to insert an item at a specific position. Then we can use the remove method to remove any item from the list that we want, or we can simply use the pop method to remove the last item of the list. We can also use the sort method, which will sort the list. We can use the reverse method to reverse the order of the list items, or we can use count method to count the total number of items present in our list. Now, just like the list, we have the tuple data type. A tuple is also used to store a collection of items, either of the same data type or different data types. To create a tuple, we use the round brackets, and the main difference between a tuple and a list is that a tuple belongs to an immutable data type, which means once the tuple is created, we cannot modify its content, like we cannot add or remove anything from the list. Also, since tuples are immutable, Python can handle them a little faster than lists, so they can give you a small performance boost in certain cases. Then we have a set data type. Just like the list and tuple, set is also used to store the collections of values of either same or different data types, but with two big differences. A set cannot have any duplicate values in it. If you try to add any duplicate values in a set, Python will remove the duplicate values. And the set is unordered, which means the order in which you insert the item will not be maintained in the output. Sets are really useful when you want to work with unique values and do operations like union, intersection, and difference, just like in mathematics. And then we have the dictionary data type. So far, we've seen lists, tuples, and sets. All of them let us store multiple values, but when it comes to the dictionary, it allows us to store the items in the form of key value pairs. So in this example, the name points to the mic, age points to the integer 28, and major points to computer science. Now to access any values, we just use the keys. So to access Alice, we can use the key name, and that will give us Alice as the output. And we can also update the value of any existing key. So if we change the value of age to, let's say, 30, and print the dictionary, then you will see that this time the value of age has been changed. And also we can add a key value pair. So if we try to add a new key city with the value of USA, then on running the program, you can see that a new key value pair has been added to the dictionary. Now there are some methods that we can perform on the dictionary, like seeing all the keys in the dictionary. We can use the keys method, which will display all the keys of the dictionary. And in the same way, to see all the values of the dictionary, we can use .values to see all the values. And if I want both the keys and values together, I can simply use .items to see all the key value pairs. And to remove an item from a dictionary, we can use the pop method, and inside it we can pass the key that we want to remove from the dictionary. And at the end, if we want to clear the entire dictionary, then we can use the clear method on our dictionary, which will remove all the keys and values from the dictionary, leaving us an empty dictionary.
Now the next concept we have is the typecasting technique in Python. So now that we've seen different types of data in Python, numbers, strings, lists, dictionaries, there's one really important thing we need to understand: typecasting. Typecasting simply means converting one data type into another. For example, let's say I have a variable called num, which stores the integer 10. So now if I want to turn this integer value into the string, I can use the str function and pass the num variable like this. So now if I check the type of new num, then you can see that it's now belonged to string class. In the same way, if I have a string that contains a number in the form of a string, I can use the int function to convert it into the actual integer value. In the same way, we can use the float function to convert any number into the float type. You can even convert the list into some other data type like set. So now if I use the set function, then you can see that now the list has been converted into the set data type. But there is something that you have to remember while converting the list into a set. If your list contains duplicate items, then on converting the list into a set, it will remove the duplicate items because a set does not contain any duplicate items in it. All right, so now let's talk about one of the most important concepts in Python: functions. Up until now, we've been writing code step by step. But imagine if we need to perform the same task in multiple places. Do we really want to write the same code again and again? Of course not. That's where functions come in. A function is basically a block of code that we can reuse whenever we want. For example, let's say we want to greet someone. So one way to do is to use the print function and write something like hello Alice and hello Bob. So if we run the program, then you can see that our program greets both the Alice and the Bob. But honestly, it's looked very repetitive because every time we have to write hello along with the name. So instead of greeting with print statement, we can create our own function in Python. So for creating a function, we will use the def keyword and then the name of the function, which in this case will be the greet. And then inside the parentheses, we'll add name as the parameter. And then inside the function, we will print hello, comma, name. Now, whenever we pass any name inside our greet function, it will going to print that name along with the hello. So now to use our greet function, we have to call it. So we will write greet, and inside it we will pass Alice. And then we will again going to call the greet function and this time pass the Bob. So now if we run the program, then you can see our program is greeting both Alice and the Bob. So again, how does this work? We first define the function using the keyword def, and then we give it a name like greet. Inside the parentheses, we can pass in parameters like name here, and then we write the code that we want the function to execute. We can also make the functions return values. For example, here, we can create a function called add that takes two numbers as a parameter. Now this function will going to add this numbers and then returns the result. So now if we call the add function and pass 5 and 3 as the parameters, and then print the result and run the program, then you can see that our functions return the sum of both numbers.
So we just learned about functions. Now let's take it one step further and talk about something a little more advanced, but super powerful, called decorators. Now, don't worry if this sounds scary at first. A decorator is basically a way to add extra functionality to a function without changing the function's actual code. Think of it like this. Imagine you have a plain cupcake. A decorator is like adding some icing on top. You still have the cupcake, but now it has something extra. So let's say we have a function that simply greets a person by saying hello to them. So if I call this greet function and pass Mike as a parameter, then on running the program, you can see our program says hello Mike as the output. But now let's say before saying hello Mike, I want to say something like welcome back. And after saying hello Mike, I want to say goodbye. But the catch here is that I don't want to change the code of my greet function. So for this, we can use the decorator function. So I will be creating a function called decorator. Now this function will take another function as the parameter. And inside this function, I will be creating another function called wrapper. And in this wrapper function, I will be calling the function that I pass into the decorator. And now all we have to do is to add the @decorator above the greet function. So what's happening here is that when Python sees this @decorator, it knows there's a function called decorator defined somewhere. So Python will pass our greet function into the decorator function as the parameter. This means that whenever we call the greet function, they are actually passed into the decorator function and executed through the wrapper function. And now we can add that extra functionality in our decorator function. So before calling the function in the wrapper, I can print welcome back. And after the function call, I can write goodbye. So now if I run the program, then you can see that Python doesn't directly call the greet function. Instead, it first runs the wrapper function from the decorator and then calls the greet function and then again runs the wrapper function. So in this way, we add some extra functionality to our function without changing the actual code of our greet function. Now let's talk about a small but really handy keyword in Python, the assert keyword. The assert keyword is used to test if a condition is true or not. If the condition is true, Python just keeps going. But if it's false, Python throws an error with your own custom error message. So let's say we have a number variable that contains one integer value. And now we will use the assert keyword and then write our condition, like if the number is greater than 0. And then we write the error message that we want to show if this condition is not true. And then in the next line, we print the message that will only display if the above condition is true. So now if we run the program, then you can see that we get number is positive as output because the above condition is true. And now if we change the number to some negative integer, then on running the program, you can see that we get the assertion error with our custom error message. It's really useful for debugging and testing. If you want to make sure certain conditions are true while your code runs, you can add asserts. If something goes wrong, Python will immediately tell you where the problem is.